It's a real my pleasure to welcome today Professor Monica Castro. Now, Monica is a professor of the Department of Plant Propagation at the University of Chile and has been working on this area, especially of subtropical fruit species, for a long, long time. She has since 2002 directed the program of selection, propagation and evaluation of especially avocado rootstocks in different conditions of Chile. And between 2007 and 2011, she was also the president of the International Avocado Society. So has been really passionate about the avocado work. She has already directed more than 60 undergrad theses and 10 postgrad theses and has published in highly esteemed journals. And for me, it's really special to have Monica because I've been interacting with Monica through the avocado brainstorming meetings and World Avocado Congress, and our interests in plant propagation, especially the focus, really aligns. So welcome, Monica, and over to you.
Thank you. Thank you, Nina. You can hear me? Yes? Good day. First of all, I'd like to thank Professor Nina Mitter and her team to their invitation to this seminar. I will talk about the advances in avocado rootstock research in Chile. Nowadays, in Chile, we have 30,000 hectares between parallel 30 and 34 degrees south latitude, with the highest concentration being in the region of Valparaiso. The climatic conditions in Quillota, the main area planted with avocado, are Mediterranean climate with long dry season, with average maximum temperature 23.9 Celsius degrees and average minimum temperature 9.9 Celsius degrees. 80% of the total area is in full production and the remaining 20% is still developing. At the end of 17th, in Chile, we had around 6,000 hectares, mainly in Valparaiso region. At the end of 80s, we had around 8,000 hectares distributed in Valparaiso and metropolitan regions. At the end of 90s, we had the double area, around 17 hectares in the same regions, plus Coquimbo regions in the north of Quillota. And in 2007, when we organized the World Avocado Congress in Chile, we had 39,000 hectares in the same regions. Currently, we have around only 30,000 hectares because in the last year we have had different problems with drought, cold, and difficulties in the airport market. In each one of these regions, we determinate the main limitation for avocado growth. In the northern area, parallel 30 degrees south latitude, the problems are the presence of carbonate salts in the soil and root asphyxia. This last problem is very common in plantations located in hillsides. The main limitation in the central zone region of Valparaiso include the replant disease and root asphyxia problems. In this region, we have the oldest avocado orchards in Chile. In the metropolitan region, where the capital Santiago of Chile is located, the main difficulties are salinity, especially sodium chloride, in both soil and irrigation water, root asphyxia and replant disease. The root asphyxia problems sometimes occur due to problems related to high water tables. The main limitation in the south border of avocado orchards in Chile, around parallel 34 degrees south latitude, include the replant disease and root asphyxia problems. On the other hand, The main commercial propagation system used in Chile is the grafting on seedling rootstocks. Seeds used as rootstock show high genetic heterogeneity signs. They are obtained from not isolated mother plantations and sometimes F2 seedling plants without grafting. All of them produce high heterogeneity in the nursery plant. The main seedling rootstock used in Chile is Mexicola, which belongs of the Mexican race, has high capacity of germination, appropriate vigor, and uniformity in nursery, is sensitive to phytophthora, to salinity, and moderately tolerant to cold. It has medium tolerance to root asphyxia, average productivity in virgin soil, bad productivity in replant condition, and its harvest is between April and June. The other seedling rootstock used is Sutano, and it also belongs to the Mexican race. It has high germination capacity, greater vigor of the tree than Mexicola, medium tolerance to salinity, medium tolerance to root asphyxia, average productivity, irregular in virgin soil, and bad to regular productivity in replant conditions. Its harvest is between June and July. The other seedling rootstock used in Chile is Naval, which belongs to Guatemalan race. It has high germination capacity, high vigor of the tree, salt tolerance, especially sodium chloride, under controlled conditions, sensitive to carbonate, low tolerance to root asphyxia, average productivity irregular in virgin soil, and bad to irregular productivity in replant conditions. Its harvest is between October and December. These characteristics cause high variability also in orchard, especially in those located on hillsides. This situation is related to the quality of the plants, the soil, and the irrigation system. Considering this background, it's important to answer the next question. Why is it important today to worry about the avocado rootstock in Chile? Nowadays, about 95% of the avocado orchards have seedling rootstock, Mexicola, and others. Additionally, tree performance is affected by soil and climate conditions. Moreover, limited productivity under limiting conditions, market, environmental, etc. Available technologies to improve yield are costly, environmental and economic, currently difficult to solve. Considering this background, it was defined that under the limiting condition of cultivation in Chile, alternative rootstocks should be looked for the present outstanding characteristics. Thus emerged the clonal rootstocks of avocado as an alternative for my country, Chile. The commercialization of avocado plants on clonal rootstock began in 2008. At first, it grew slowly. Until today, reaching the production of 200,000 clonal plants per year. The increase in the number of clonal plants marketed in Chile was possible thanks to the development of an implementation of cloning technology, etiolation and layering, Brokow method, and obtaining promising results in local trials of rootstock evaluation. The stage of avocado clonal propagation based in foliage and plant techniques are the following: obtaining seed precondition, growth of plumule, grafting of the clonal rootstock, entrance to the etiolation chamber, rooting of the etiolated stem, grafting with commercial variety, acclimatization and transplant to 12-liter container, and the formation of clonal plants. The stage 1 to 8 are the most complex and costliest because the biggest losses take place, around 50%. In the final stage, the formation of clonal plant only occurs between 0 and 2% of losses. On the other hand, the fundamental aspect of the clonal avocado propagation are to have qualified staff who are committed to their work, use heating in all the process, use nurse seed with large caliber, the management of rootstock and variety mother plant, and worry about the development of a good root system around the perimeter of the stem. Based in this information, the School of Agricultural Science of Pontificia Universidad Católica of Valparaíso in Chile, together with several companies of the sector, developed different research projects in order to study the effect of plant material on the increase of the avocado's tree productivity. We have 8 experimental plots. All of them represent the main edaphic and climatic limitation described above that affect the avocado orchard in Chile. Due to lack of time, we will only analyze the result of any plots, mainly the oldest of them. Cabildo experimental plot is located in 32 degrees south and 71 degrees west. In this plot, we work with Dusa and Toro Canyon clonal rootstock and Sutano seedling. The characteristics of this plot are virgin soil, south-facing hillsides, and we don't use gilding and growth regulators management. In this trial, the clonal rootstocks have shown promising results. After the evaluation of production, has on Dusa rootstock obtained the highest amount of kilos per plant, being statistically different from other rootstock evaluated in 3 evaluated periods. If we consider 666 plants per hectare, a production of 23,000 kilos per hectare is obtained at the end of the 3rd harvest using Hass on Dusa clonal rootstock. The evaluation of alternation rate, which indicates alternative fruit-bearing index, showed no statistically significant difference between Dusa and Toro Canyon rootstock over 4 years, but both showed difference with Sutano seedling rootstock. This picture on the left shows lateral regrowth from autumn roots that were already lignified. In the other photo, at the right, we can see the development of pioneer roots in Dusa under canopy area. This picture was taken in November in springtime in Chile. Next, we will analyze the result obtained in the experimental plot in Quillota. Here we have 2 dates of plantation. This orchard is located in Pocochay, 33 south degrees, and it was replanted without special management. It has clay loam texture and it's a south-facing hillside. We don't use intensive management such as gilding and growth regulator. In this plot, differences have been observed in regard to replanting soil tolerance, better tolerance using clonal Duke 7 in comparison with seedling rootstock from different races. For the alternation rate variable, which represents alternate bearing index over 4 years, just like in Cabildo plot, has on rootstock Duke 7 present the lower alternance compared with all the seedling rootstock evaluated. Naval, Guatemalan race, Mexicola, Mexican race, and Ashdod, West Indian race. We established in the same orchard another trial using clonal rootstocks Dusa and Duke 7, and as a control, the seedling rootstock Mexicola. This experimental plot, number 2, is in replant condition as well, south-facing hillside and without girdling and growth regulator management. When we analyze the effect of rootstock on yield, the comparison was conducted by year. In the first harvest, no statistically significant difference was obtained between the 3 rootstocks. However, in the second and in third harvest, Hass, Ondusa, or Duke 7 presented the best production. When we observe the effect of rootstock on fruit weight, clonal Duke 7 presented the highest result without being different to rootstock Dusa. If we analyze the variability in yield between plants on the same rootstock, can be seen in this graph that Hass on Mexicola are more variable and that the average is not a good descriptor of this situation. Moreover, Hass on Dusa showed less variability in production between plants, and in this case, the average is a good descriptor of this response. On the left, we can see the rhizotron evaluation in the field experiment with seedling rootstock Mexicola with lowest amount root development than Dusa clonal rootstock on the right, which has a vigorous root growth development. In this picture, we can see a new commercial experimental plot of 5 hectares planted in a replant condition in the same avocado orchard in Pocochay. This situation is doing frequently in the avocado orchards in Chile due to the age of the orchards. In this commercial experimental plot, we evaluated the yield. In the first harvest, Hass on Dusa and Hass on Toro Canyon had the best result. In the second harvest, Hass on Dusa is better than the other rootstocks. As you can notice, the difference between the yield in Hass on Dusa versus the average of the orchard is almost 6,000 kilos per hectare. According to the previous result presented, it is important to ask the next question. Are clonal rootstock a valid alternative for Chile? The clonal rootstock under the Chilean condition allowed to increase the productivity to an additional of 20 to 60%. On the other hand, the clonal rootstock under the Chilean condition allowed to increase the fruit size for exporting quality in 20%. The quality is very important. At least in Chile, avocados are consumed daily by both kids and adults. So we must assure they are eating healthy food. For example, in this photo, you can see my youngest daughter, who loves the Chilean avocado. Also, the clonal rootstock under the Chilean condition allowed to reduce alternative bearing index from 0.8 to 1 versus 0.2 to 0.4. Finally, I would like to thank undergraduate and graduate students who have collaborated all this year in accomplishing several trials, and, of course, my gratitude to permanent staff from the propagation laboratory of our school. Without them, all these advances would not have been possible. I also think it is important to praise the support given by the companies participating in the project. We all make a very good team. Thank you very much.
Thanks, Monica. Any questions for Monica? Monica, I do have a couple of questions. So, you talked about clonal now in Chile using the etiolation Broco method. So, what's the time? How much time does it take for you to get a clonal plant ready, and what's the cost in Chile like?
Okay. Maybe 18 months.
18 months.
Yeah.
Mm-hmm.
It's similar that we have for seedling rootstock, when we use seedling rootstock.
Mm-hmm.
And the cost is very high.
Is
the
it?
cost, yeah. And now in Chile, the cost is $20 for clonal plants. Yeah, and when we use seedling rootstock, the cost of the plant, the price, not the cost, the price, the price is 3,000 pesos.
Around $6 Australian.
$6 for a seedling plant.
Yeah.
20 US for.
Yes. Yeah. But at this time, when if you remember the graph that I show you, yeah, the demand of clonal plants now is very high. 2 weeks ago, we have a meeting in my university, and in this meeting participate different nurserymen and growers from avocado and citrus. And all of them say that the result with clonal rootstock is very important, and they are dispuestos, willing to use this plant, because the result is very, very important. And any of the speakers show the result, and they explain that in the third harvest, the growers can pay the value of the plant, because the result, especially in replant condition, is very, very different. Because when we use Mexicola or Sutano or Naval, any of seedling rootstock, in this condition, we have a lot of diet of the plant.
And is there a short, like when I visited South Africa or here in Australia, we hear about shortage of plant supply. Like you're saying demand is increasing to 200,000 plants per year in Chile. So how is the plant supply coping with it? Like nurseries, are they producing enough, or there is a backlog of orders? Or?
It is very difficult, because in Chile we have only 4 nurseries that produce nowadays the clonal plants, and only one of these nursery produce the plant from seedling. Began with seedling. I don't know if you understand, because in our university we produce the, we use the name of plantain, and I don't know if it's possible to show. Because the nursery is very difficult to adapt this system. In my lab, we have an clonal unity that we offer the plants in this condition.
To the growers.
Yeah.
Okay.
To the nursery, and we develop the step 1 to 8, and we spent the plant to the nurseryman, and they put in the container, big container, and acclimatization, and then sold to the grower.
So you operate this system from the university?
Yes.
Like
Yes.
And
Because
cost to the nursery, or you sell to the nursery, or
we sell to the nursery. Yeah, because when we obtain the best result in the orchard with the clonal rootstock, at this moment the nurseryman said it's not very convinced that they use this type of plant. And in our university, we think that it's very important to push the industry.
Okay, thank you.
Yes.
So I'm curious to know, how many plants are you supplying to industry at the moment, each year?
Each year, more or less 5 or 400. 400,000. We use very high density. In Chile, we use very high density, more than you use in Australia. Sorry.
Sorry, can I just clarify?
Yeah.
You're producing 400,000 plants a year to supply to industry?
Yes.
Using university resources?
Usando recursos de la universidad.
No. In my faculty, we produce only a little bit of plant that push the industry that produce the plant in the nursery. Do you understand? And
¿Cuántas plantas tú le vendes?
yo. Okay. I don't understand. In my clonal unit, we produce this year 40,000 plants. Yes. Sorry, I don't understand the question. Sorry.
Yeah. 40,000 is great.
Yeah. All the plant that in Chile spent this year is 100,000 plants. But in Chile, we use very high density.
What is the density?
The density is between 5.3. Then we have 666 plant per hectare, or maybe any growers use 1.1 density. It's very, very high, because in Chile the growers use growth regulator, gilding, and a lot of management, special management for this situation.
Did they ever try those really high densities on a seedling rootstock? Because I'd imagine if you tried to go at that density and that management strategy on a seedling rootstock, all your plants would respond differently, so that would be a big challenge. So are all those high densities on clonals or seedlings?
The growers don't difference between clonal of seedling rootstock nowadays. I think that the more conventional density is 5 per 3 meters, and but it's very different between the different situation, because in hillside the growers use more density because the result is not too good, and if has the possibility to cut the plant and obtain more behavior of the plant.
Any more questions? Right, we'd like to thank Monica for an exciting presentation.
Thank you very much.
Thank you.